For x greater than 0 and less than or equal to 2, the curves with equations y equals 4 log x and y equals root x intersect at a single point where x equals alpha. Show that alpha lies between 0.5 and 1.5. Show that the equation 4 log x equals root x can be rearranged into the form x equals e to the root x over 4. Use the iterative formula here with x1 equals 0.5 to find the values of x2 and x3, giving your answers to 3 decimal places. And figure 1 on the opposite page shows a sketch of parts of the graph of y e to the root x over 4 and y equals x, and the position of x1. On figure 1, draw a cobweb or staircase diagram to show how convergence takes place, indicating the positions of x2 and x3 on the x-axis. Okay, so let's have a little look at this then. Show alpha lies between 0.5 and 1.5, where the alpha is the intersection point. Okay, if we do the difference then, which I've started to do here, 0.5 and 1.5, then they should be opposite signs, shouldn't they? 4 log x and root x. Let's just check that's correct in the question. So I'm just going to go back up for a moment and just check the question, sorry. 4 log x and root x, yeah, that's fine. Just had a moment's thought that they weren't correct. Okay, so calculator then. Let's have a look then. 4 times log x, 4 times ln of 0.5, minus, oh, we need a bracket, minus the square root of 0.5 equals minus 3.47. Now let's try 1.5. Okay, so let's go back and change the 0.5 then to 1.5 here and here. And this should now be positive. 0.397, which is positive. Change of sign. Sign. So a root must lie between y equals 4 ln x minus the square root of x. Okay, that's part A done then. Show 4 implies can be rearranged to be written in this form. So 4 log x equals root x then. Part B, 4 ln x is equal to the square root of x. Okay, so ln x, move the 4 up to the power using properties of logs is equal to x to the half, or root x. Now this is log base e, so unwrap the log, so x to the 4. The log base e, the e swings up and hits this into the e root x. I'll put it as root x, looks easier on the eye. So x to the 4 equals e root x. Take the 4th root then, so that tells us then x is equal to e to the root x to the power quarter, which is equal to e to the root x power u times, so it's x over 4, isn't it? Which is what we wanted to show. Okay, so we've done there. We've done part B. Use the iterative formula then, with x1 equals 0.5 to find x2 and x3 to 3dp. So part C, xn plus 1 is equal to e to the root xn over 4, and x1 was equal to 0.5. And we need to find x2 and x3. And it was to 3 decimal places, I believe. Yeah, to 3 decimal places. Okay, let's have a little look at this thing. Let's get the calculator. So, e to the root. So, e to the power square root of 0.5. Put 0.5 in there, 0.5. Outside the square root, divide by 4, Okay, so let's press equals there. So, okay, so we got 1.19. No, I'm going to start again there. I'm going to just put 0.5 in the calculator. Now that's gone in as answer. So now what I'm going to do is I'm going to, of course, do Shift E to the power square root of answer, which is 0.5, divide by 4, come down to ground level. Okay, equals 1.1933 dot dot dot. And if we press equals again, because answer's gone into here, and that will just recalculate it here, 1.3140. So the 3dp 1.193, and this is equal to 1.314. I'm just going to have a quick look at that number, make sure I wrote it down correctly. Yeah, that's fine. So there's x2 and x3 for part C. Okay, figure 1 shows this curve and this y equals x, and x1, draw a cobweb staircase diagram to show how convergence takes place, indicating x2 and x3 on the x-axis. Okay, so our iterative formula then is down here somewhere. So now I'm going to drag that and take it with me so we can have a look at it with the sketch. Okay, good. So let's go down to get the sketch then. So here's the sketch. So let's have a little look at it then. We start at x1, we input x1 into the function there, and then we've got our next value here, which we then need an x value for. So here's the y equals x line, so that will be the value, the new x value that was the former y value. So there's the vertical line there. So I'm going to go back up to the curve and then do it again here, and that would be the new value. Not drawn very well here, but you can see that this would be x2 and x3. So this would be x2, this would be x3. So basically you inputted the first value, you went up to the value of the y, which it calculated, then you put it back in the y equals x value to get your next input value, and then you go up there and you get your next one, which is your x3, reflect it through the x3 line, the y equals x line to go there, and then you put it in again and again and again, and you see these steps emerging. So this is just a sketch based on the printout in the actual paper of the plot, which would be much more accurately drawn, of course, and this would show it much more clearly. So I think that concludes the question.